Hello everyone, I'm Edu and I'm currently here today to present about my final project on physics. My final project on physics is basically rating movie scenes on their physics, if it's realistic or not. So my first movie scene I'm gonna be looking at is Richard Donaldson 1978 Superman. In the scene, Lois Lane had fallen off a building and fallen, but Superman came on time and rescued her midair. My question is, wouldn't Lois have sustained a few injuries when falling into Superman's hand? The research I used was kinetic linear motion and work energy power. My hypothesis is if Superman was stationary when he catches Lois, then Lois would have sustained a few injuries. So here's my calculation to prove my hypothesis. The given is lowest initial velocity was 0 meters per second. The time it took Superman to catch her was 10 seconds. Uh, Her acceleration was 9.8 meters per second squared. So after this, after we've gotten all the numbers, we're gonna try to find its velocity. So the formula we use is velocity equals to initial velocity plus acceleration times. So it becomes v equals to 0 plus 9.8 times 10. So v equals to 98.0 meters per second. After we got in the velocity, we need to find its kinetic energy. So first we need to find the mass, and the mass of Lois is 55 kilograms. So the formula we use equals to key E equals to 1 divided by 2 times mass times velocity to the power of 2. So key E equals to 1 divided by 2 times 55 times 9.80. So the key E equals to 264110, J or NM. After this, we need to find the force of how Lois was caught in Superman's hand. So the force was force times 20 equals to 261110, and we moved the 20 to the right, so F equals to 261110 divided by 20. That equals to the force equals to 13,205.5 newtons. And my conclusion is Superman is supposed to be stationary when he grabbed Lois, which means Lois would come to a screeching halt, losing all her speed in an instant. Lois would have experienced incredible force when she landed on Superman's arm, and the amount of force would leave her severely injured. After this, my rating on the scene, my rating is PGP 13. Children under 13 might be tricked into thinking the physics were pretty good. So my next scene is from the Batman. In the scene, Batman was running away from a car with a woman in tow. After he got into a dead end, he fired his grappling hook on a building and basically carried him and the woman out of harm's way from the car. My question is, would the device be able to emit enough power to lift an adult human up? When I mean device, I mean its grappling hook. The research I use is work energy and power. My hypothesis is if the device grappling hook wasn't able to emit enough power, then the Batman and the woman would not be able to escape the car. So here's my calculation. First we need to find the newtons. So mass of Batman is 80 kilograms, so 80 times 10 equals to 800 newtons. The mass of the woman was 56 kilograms, so 56 times 10 equals to 560 newtons. So the newton total is 800 plus 560 equals to 13 and 60. After we got this, we need to find the height, so basically the distance. So the distance, we assume that one floor equals to 5 meters, so one of these squares is only 5 meters. And because we saw in the scene that Batman was grappling until the third window, so 5 times 3 equals to 15 meters up. After this, we need to find the height of the actor that is playing Batman. We found it, and it was 1.75 meters. So the distance is 15 minus 1.75 equals to 13.25 meters. After this, they're gonna go over here. So first, the time that it took for Batman to actually climb up was 7 seconds. So after this, we need to try to find the power. The power equals to R times V. So power equals to 1360 times 13.25 divided by 7. So the power emitting by the grappling hook is 2575.26 watt. So my conclusion is Batman's grappling hook would be too small to carry enough energy to lift the power of 2 people. My review is basically it's pretty good physics. A lot of people definitely be tricked, but a lot of people would have just not overthink it and still believe and want to believe that a grappling hook size of a gun would be able to carry you. So my next scene I'm gonna present is from Deadpool.
Superhero landing. She's gonna do a superhero landing. Wait for it!
In the scene, there was a superwoman up on a high place, and after she saw Deadpool and his friends below, she jumped down from her high place down to Deadpool and did a superhero landing. My question is, can the woman be able to do the superhero landing without hurting herself? My research requires Newton's law of motion, and my hypothesis is if the woman did that superhero landing, that then she would have sustained heavy damage. So here's my calculation. First we need to find the mass of the woman. The mass of the woman is 90.71 kilograms. The time it took for her to jump down from her high place was 3 seconds. And the density of her was 1.22 kilograms per meter. After this, after we got all that numbers, we're gonna put it into formula. V equals to the square root of 4 times mass times gravity divided by density times acceleration. So after that, we're gonna put it. So V equals to 4 times 90.71 times 10 divided by 1.22 times 1.8874. The V equals to 59 meter per second. After we got that, we're gonna put it into another formula. F equals to M times V divided by T. So in this calculation, F equals to 90.71 times 59 divided by 3 equals to 1783.963333. We're gonna just round it to 178 newtons. My calculation is the woman would have sustained multiple injuries, heavy at that, because when she jumps down, she suddenly stops, and the force that she would have injured her. My review is RP, wretch, because even though nobody would have survived that without at least getting a bruise, this is a superhero story and the woman have superpowers, so in their universe it's probably plausible that she won't get hurt. Thank you everyone for listening to my final project video, and thank you for listening. Goodbye.